We've shown you in the previous video how it's quite easy to extract pure paracetamol from tablets using an organic solvent such as acetone, ethanol or isopropanol. Acetone is our favorite as it's efficient and easy, and evaporates quickly leaving crystals like this. Paracetamol is an amide as you can see from the structure here. An acetyl group joined onto a para-aminophenol molecule. Today we're going to try out an amide hydrolysis and see if we can make and purify para-aminophenol. Hydrolysis can be done under either basic or acid conditions, but first of all let's try using the alkali process. Here we've got 5 grams of paracetamol which we previously extracted from analgesic tablets and recrystallized. It's been in storage for a little while and it's got a very faint pink color, but it should still be quite pure. Okay, to do the hydrolysis we're going to use sodium hydroxide. Here we've got 4 grams which is a 3 times molar ratio to the paracetamol we're using. Let's add an ice cube and 10 ml of water, and dissolve. Okay, this is looking good. Okay, for the reaction we're just going to use a 100 ml flask. We've got this set up on a hot plate and with good magnetic stirring. First of all let's add the sodium hydroxide solution. And we'll get this stirring nicely. So now let's add the paracetamol. Okay, all in. So we're going to gently heat the mixture now. Some of the solid seems to have dissolved as you can see, but let's see what happens when we heat. Well, the solid mostly seems to go into solution, and we've also got a faint pink color appearing in the mixture as well. Let's leave this to warm up slowly and see if we get a reaction. We've covered a mechanism for alkali hydrolysis of amides in a previous video, so check it out for more details. But let's have a closer look at paracetamol because it's an interesting molecule. Paracetamol is the acetylamide of para-aminophenol. And despite the benzene ring, phenols like this are quite reactive. One reaction they can easily undergo is oxidation. When paracetamol and related phenols oxidized they can form compounds known as ketones. These ketones are highly reactive and ultimately end up forming complex dye-like compounds with very strong colors. The slightly pink color in the paracetamol we use is due to the tiny presence of these compounds formed by atmospheric oxidation. In fact, phenols tend to oxidize quite readily in alkaline solution and with heat, so we're running a bit of a risk with this reaction. But let's see how it goes. When you take paracetamol for a headache, your body processes it into water-soluble compounds which can be easily excreted. These compounds are relatively non-toxic, and as you can see from the structures here, they still contain the intact benzene ring and amide group. But there's a limit to how much your body can process in this way. If you take more paracetamol than your body can process, then your body has another way of trying to remove the paracetamol. And just like it does for other compounds you might ingest such as ethanol, it attempts to oxidize the paracetamol molecule in order to turn it into something highly water-soluble and easily excretable. But there's a catch. The body can oxidize paracetamol pretty easily, but the resulting compound is a quinone known as NaPQI. And it's highly reactive. Just like it rapidly polymerizes and forms red dyes when heated in solution, if it's formed via oxidation processes in your liver, it will react with your liver and destroy your liver cells. So paracetamol is a very useful and safe drug in normal doses, but in large doses it can be very toxic. Worse of all, the destruction of your liver occurs slowly in an irreversible process. A couple of days after taking an overdose, just when you thought you were okay, you'll start to feel unwell and then slowly die a terrible agonizing death from slow fulminating liver failure. Apart from a liver transplant, there's nothing the doctors can do. Even fentanyl won't relieve the pain. So treat paracetamol with a lot of respect. Don't be scared of it, but always read the instructions carefully and try to take the minimum you need to. And if you do think you've overdosed, don't wait for symptoms. Go to your emergency room immediately. The mixture is heating up now, and as you can see, the color is starting to turn a bit darker. And if we stop stirring temporarily, you can see that there's also a solid forming in the hot mixture. We're going to leave this hot mixture stirring for an hour in order for the amide hydrolysis to complete. Here we are an hour later. The mixture is quite dark, as you can see. We stop stirring and allow to cool. As it cools slightly, there's a brown flocculent precipitate forming in the mixture. So the first thing we're going to do while the mixture is still warm is filter it. We wash the flask out with some water and then wash the solids in the filter. There's a small amount of insoluble residue, possibly unreacted paracetamol. Now we've got the beaker set up with a stir bar in it, and we're going to place our filtrate into here. About 80 ml total volume. Well, in order to get our hydrolysis product out, we're now going to need to neutralize the excess sodium hydroxide and convert the sodium phenolate salt back into the free phenol again. So let's get our filtrate onto a stirrer and get it stirring well. And here we've got 10 ml of concentrated hydrochloric acid, which should be more than enough to bring the solution to neutral. We'll need to be careful not to over-acidify, otherwise the amine group in the aminophenol will form a water-soluble hydrochloride salt. So we'll need to check the pH carefully as we add the acid until we get to neutral. Let's get a bit in and start neutralization. pH is still strongly alkaline, so we've got a way to go. The mixture warms slightly and neutralization takes place. Slightly less alkaline now. Towards the end we add the acid drop-wise carefully. Definitely at between pH 6 and 8 now, although the color of the liquid makes it hard to tell. So we covered up the mixture and now we're going to chill it down for a few hours in order to see if we can any product coming out. Paracetamol is soluble in warm water but pretty insoluble as the temperature drops below about 10 to 15 degrees. As the liquid chills you can see yellow crystals forming. And here we are with chilling right down to about 5 degrees. See lots of crystals in suspension in the mixture. So let's filter. And we get these as dry as we can. Okay, here's our crude product. We didn't bother to weigh it as it is still quite a brown color. The pure compound should be white, so this obviously has impurities and decomposition products in it. The easiest way we can think of to purify is simple to recrystallize this from warm water, so let's give it a go. We've got the crude product in a beaker on a hot plate. We'll get a little warm water in here to start with, about 10 mils, and then see how we go. Added a little more water and now warming gently. Okay, we've got everything in solution using about 40 mils volume in total. But as you can see, there are some dark black colored insoluble impurities floating around. So let's filter the hot mixture and remove these first. Okay, we've captured the black bits. Here's the hot filtrate. And just as before, we'll chill this down now for a few hours and see if we can get a pure product to crystallize out. And here we go a few hours later. Lots of yellow-brown crystals. So let's filter and see what we get. And our recrystallized product, 2.8 grams of aminophenol as dry tiny crystals. But it's still brown. This substance is a bit like anthraquinonic acid. Trying to purify by recrystallization is quite difficult and results in dark decomposition products forming. Well, if it's pure, this represents a 78% yield on our starting paracetamol. Remember that some of the weight in the original reactant is lost as we hydrolyze and remove the aceto group. So this isn't bad. We'll try this in the follow-up reaction and see just how pure it is. There are probably some other options as well for dissolving it in dilute acid, and then neutralizing and precipitating out like we did before. The product might be more stable in an acid solution, so perhaps this will give a cleaner looking product. Paracetamol is pretty cheap and commonly available, so we'll perhaps also try and see if it can be hydrolyzed using dilute acid as well as alkali at some point in the future to see if this is also a cleaner method. So stay tuned for more reactions and to see what we've got planned with our aminophenol product.